Hello, everyone. We are from the Clean Snowmobile Enterprise, presenting on our senior design projects this year for the 2023 Design Expo. Our first project that Ben will be going over is dynamic air suspension, and I, Derek, will be going over the cylinder deactivation project.
All right, so a little bit about the Clean Snowmobile Enterprise, if you're unfamiliar. We kind of have some team goals. So we compete in a competition every year, kind of focusing on lowering emissions, making a quieter snowmobile, making a better handling, and just keeping a good or better rider experience for riding the snowmobile. So at the competition, we compete in two categories. So CI, which is compression ignition, so diesel, and then also spark ignition, so just 91 octane gasoline class. And for the 2023 competition, we placed third place, or we got third place overall for the CI class and fourth place overall for the SI, with quite a few schools in each of those categories. And we also got awards for best value benefit for the CI, best sales presentation for CI, fastest acceleration for CI, and we also placed first in the objective and subjective sound class, or sound in the CI class. And then for our project specifically for the capstones this year, the first one we're going to be talking about is the dynamic air suspension. So for this project, we had a couple design objectives. So the main one was to improve subjective and objective handling of the snowmobile. So we thought that with an air suspension, we could make it a little bit smoother. And then also, hence the smoother, we would reduce NVH. So that's kind of our goal going into this and kind of what we thought we could improve by implementing air suspension. The project deliverables, there are quite a few of them, but the first one was replacing the rear skid shock. So replacing the stock shock with the airbag that was graciously sponsored by RideTech. We also had deliverables to find a tank and a compressor. So see in that picture there with our tank and compressor mounted on the tunnel of the Yamaha Viper. So we did quite a bit of research to find the best compressor and tank kind of setup that we could find that would be good for our application. We also did custom controls, so we were controlling the air pressure in and out of the tank, or in and out of the air shock, and kind of using solenoids to add and remove air from the bag. We also made modified brackets, so the stock brackets rubbed with the larger shock, so we had to make modifications there. We also did CAD and FEA for validation, and then tested all of this on the test bench and on the snowmobile. If you want to go to the next slide. So the results of this project, it was a successful implementation. So we put it all into the snowmobile. Derek, if you want to play that video real quick as I'm talking. There we go. That's, you can kind of see it moving through the range of motion. And then we can adapt the ride stiffness. So we've got a switch that'll can raise or lower the bag pressure. There's a display that shows that bag pressure as well. So once we got this on the snowmobile, we tested the results, and we did show that it improves subjective handling, and we do require more testing to determine the changes in NVH that we're seeing on the snowmobile.
Our next project that we tackled this semester was cylinder deactivation. This is comparable to how newer vehicles with big motors deactivate cylinders when they don't need all the power of the motor. Our 3-cylinder Yamaha Viper engine was the engine that we chose to do this with. I have a short video of it here running on just 2 cylinders, and you can see that it runs just fine. It doesn't shake or vibrate or anything, and it works like it should even when it's running on 2 cylinders. So I'll play that real quick. So that was just a short dyno pull with that motor to kind of validate the project. And then the picture right next to that is our test bench. That's not the fully finished one. It is done now, but I did not have an up-to-date picture for that. But basically, that'll just allow you to see kind of how the injectors are firing based on different scenarios with different amounts of load or throttle position. And from there, that gives you kind of an idea of what's going on inside the engine, and it gives you a visual on things like fuel economy or efficiency. But the biggest thing with this project was to develop the method for controlling the injector firing. That's more, of course, you can't completely see that. That's more on like the coding side. And then we also set out to collect the dyno data to prove the effectiveness of the project. And for the competition, we wanted to improve the fuel economy and performance during the endurance event. The event it's a trail ride where they measure how much fuel you use and how long you can make it on basically the lowest amount of fuel. And another big part of this project was to leave little to no effects on the rider experience because we didn't want you to even be able to tell that the cylinder was being cut out. So it was very important to implement it in a way that made it feel like a stock snowmobile, but perform better. So our final recommendations, we recommend that Clean Snow continues testing both the designs and keep them implemented on the sled. And of course, with more testing, the designs hopefully get improved even more and become even more effective. I think that's all we have for you today. I want to thank you for your time. And yeah, that's all. Ben, do you have anything else to add?
I did not. Yeah, like Derek said, thank you for your time, and we're excited to be showcasing a little bit more about these projects at our booth at Design Expo this coming week. Look forward to seeing everyone.